All right, so I've been waiting for this problem, and it's finally here. So let's see if you guys know what I'm talking about. So hang on, sorry, one second. If you look at this problem, hopefully you'll know it's your favorite definition of a derivative problem. I don't know, maybe you're good at these problems, but when I was in high school, I did Calc BC, but it was still there as well. I always hated these, but this is actually really simple. So let's go ahead and try and solve it. And sorry, I know I'm talking a lot, but one last thing. I was always told to just like memorize how to solve this. They're like, oh, you take the derivative of this or whatever. And I don't know. I don't like memorizing stuff. So let's think about this intuitively, okay? So let's go ahead and write it out. As h approaches 0 for the natural log of 4 plus h minus the natural log of 4 divided by h. Okay, now if I do a direct substitution, what happens? Well, let's just try it. So the natural log of 4 plus 0 minus natural log of 4 divided by 0. Well, first of all, we get a divide by 0 error, but you know what? It's actually worse than that because look, natural log of 4 minus natural log of 4 is 0, so I actually have an indeterminate form here, 0 divided by 0. So, that's not a good thing, but actually, you know what? It is a good thing because I can use L'Hopital's rule. So again, because I have that indeterminate form, I will use L'Hopital's rule. Sometimes people write it as like L'Hospitals, but anyway, and I'm probably butchering pronunciation, but that's okay. So what I'm going to do is I'm going to take the derivative of the top and the bottom with respect to h because h is technically our variable here. So I'm going to have natural log of 4 plus h minus natural log of 4. And then I will divide all this by the derivative of h with respect to h. So this is a constant, and it's going to go to 0, and the derivative of h is going to be 1. So I'm going to have, wait, hang on a minute. Is that, yeah, yep, okay. It's going to be 1, sorry. And then the derivative, and I'll go ahead and make a separate thing here, the derivative of the natural log of 4 plus h, well, that's just going to be the derivative of the inside, or I should say the derivative of the argument divided by the initial argument. So I'm going to have 1 over 4 plus h, because the derivative of 4 plus h is 1, and then, the other thing. So I now have 1, and I'm going to get rid of divide by 1 that was previously there because it's just 1, right? Or it's just whatever, is on top. So it's going to be 1 divided by 4 plus h. So now I'm going to go back and try the limit again. So the limit as h approaches 0 for 1 over 4 plus h. If I substitute in for 0, I get 1 over 4. Sorry, I know I'm kind of writing sideways. Let me go ahead and do that again, just so you see what I did. It's a little bit more clear. So again, I had the limit as h approaches 0 for, it was 1 over 4 plus h. Now I can directly substitute in for h as being 0. So I have 1 over 4 plus 0, which is just 1 over 4. And therefore, the correct answer is B. So hopefully that makes sense, how you'd solve that. But yeah, you can use the same line of reasoning for really any definition of a derivative problem, and it should give you the correct answer. So yeah, that's it. If you have any questions, feel free to comment below. I know I went through that kind of fast, but yep, that's all I got. Yeah, I'll see you guys in the next video.